Okay, so once you are at this template, you are going to make a copy. So you do make a copy. And you get a copy. Now, let's save it somewhere else other than this. Folders are relevant all. And really, I'm just going to delete this anyway, but we'll do it again anyway. So you save it in your Project Lead the Way folder. This is technically chapter 4. Okay. Here. More. Okay, select. Okay, so once we have this, and I told you, spoiler alert, this is what it should look like. Isn't that pretty? Once you have your spreadsheet copy, you were to edit it. You are going to have to do another one of these where you yourself are going to put the data in, etc. So you are going to copy these 2 columns. We don't really care about the stations. We're talking about annual runoff over an area versus, annual rainfall versus average runoff. So once you have highlighted those areas, go to Insert, and then go to Chart. And you get a pretty good looking table. I'm going to put you guys at the bottom here. So we have a scatter chart. That's what you should have. And I have average runoff from area versus annual runoff versus area. That works for me. If you want to abbreviate that, fine. I already my labels set, so that's pretty good. Any questions so far? I muted some of you, so is there some stuff going on in the chat? Just to make sure. I hear typing. Chat. It will not let me look at the chat while I'm typing. I can hear. Who is
me?
Yes.
Are we doing part 2 today?
You will do part 2 on tomorrow on your own. That will be your assignment while I'm at the funeral.
Ah.
Okay, so once you have done that, you need to go to customize. There are things that they ask you to do. So chart style, you can mess with the colors. It really doesn't matter. The font, that is a you problem. Going down to chart and axes titles. Like I said, you could do average. You could abbreviate this if you want. Because that's one heck of a title. Okay. The other thing that we have to keep in mind from this particular section is that you can change more than one thing. So we don't really need a subtitle. Horizontal axis title, they've already named that for us. If yours didn't, this would be where you change it. Vertical axis title, that is also right. And they're gonna ask you this in a minute, but domain versus range. What is independent and what is dependent? So in this case, the rainfall is independent and the runoff of the water depends on the rainfall. So X is your domain, it's our independent variable, and our runoff is our dependent variable. It depends on the rainfall, and that's where we get that. So that those are in the correct positions. In series, you could do all sorts of stuff like make your points stars and make them bigger and all that kind of fun stuff. That is a U problem as well. This is where we need to make sure we have stuff. You can do data labels. I kind of like them. They're not necessary though. It gives you the value of each individual point. We also need to put in our trend line. That is important. Our trend line is what the whole point of all of this is. And we want to label that equation. And so now at the top, it tells us the equation of that line that is the best fit for those points. We also want to show the R squared value. So if you look, our R squared value is 0.922. The closer it is to 1, the more accurate the line at predicting the data. Okay, I will say that again. The R squared value, the closer it is to 1, and we are very close to 1, the closer it is to 1, the better it is at predicting the data. You should have all of these things at this point. Do we have any questions so far?
Where it says where it has like the 0.619 times X,
Yes.
how did you get that?
I went to label under trend line and said use equation.
Oh, okay, thank you.
Right now, this is our legend. It says position auto. If you really want to, you can move it to the bottom, you can move it to the right, you can move it to the left. That's again a U problem wherever you want it to be. Right. Wherever you want to put that, I don't really care. Horizontal axis. Treat labels as text. That does goofy things. You don't want to do that. You don't want to reverse access order. They did say that they wanted you to go -5 over in both directions or just one direction right now. And when we were talking yesterday, somebody said, oh, well, it's the lowest value is 0. And that's just not true. The lowest value is 21 and the highest value is 45. So let's go back. And we were talking in horizontal axis. So if our minimum value is 21 and we're going 5 below, we want it to go 16. If our maximum value is 45 and we want to go 5 above, that would be 50. And now we can kind of predict data a little bit further than what we have. And this line is bothering me. I'm putting the legend back at the bottom. There we go. So now I have a bigger graph. Other things we can do in horizontal axis, we do not want it to be able to hide data. That makes us sad. We don't want to hide any of the little data that we have. Scale, not going to scale. Slant labels, that's just a silly thing where we can make those labels at the bottom go at an angle. That's again, something that you could do if you really wanted to. Actually, if we do 15 here, I think it'll label it better. Oh, 15, there you go. Now we have it by 5s and it's, who doesn't like prettier data? Vertical axis, we don't need to make this any bigger, I don't believe. We've already extended it. You can, again, mess with the colors, but I don't care. Grid lines, I like to add grid lines, but you don't need to. If we look, everything is by 5s. So we have our major grid lines. If you want the little grid lines inside, you can also have little grid lines by 5 so you can see exactly where everything is. And you could do the same thing for the horizontal axis, but that is, again, not completely necessary. Do we have any questions on how I form this graph? Okay, So you're going to finish 4.4. So we've just created a scatter plot and we formatted the axes and labeled them and titled it. We added a linear trend line and include the equation on the graph. We included it underneath, that's fine. Screenshot your graphical model. You're going to do that in your portfolio. Would you describe the relationship between the average runoff and the rainfall as a strong, weak, or neither? It's a strong correlation, and the evidence is the R-squared value is close to 1. I have no idea what that was. Use your mathematical trend line to respond to A through F down here. Rewrite the trend line in function notation. Well, really what they want you to do is R of W equals, and then whatever that equation was, it was like 0.69926 dot, or excuse me, W plus whatever it is that equation was. What is the domain of the function? Well, we talked about that. The domain of the function is the rainfall. Now, what values for the rainfall would make sense? Would a negative rainfall make sense? Negative rainfall makes sense. We have water coming from the earth.
No,
Okay, thank you,
you
Andrew.
can't have.
So the domain of the function is going to be 0 to, I would hope not infinity, but x is, or w is greater than 0. What is the range of the function? Okay, so what values make sense for the range? Well, we can't have the runoff of the water be any bigger than the rainfall, because that would be weird. So that would be something that you can talk about. What is the slope of your trend line? Notice the trend line is y equals mx plus b. In y equals mx plus b, what is the slope? So in this case, it was 0.6992. So for every, okay, so that's y over x. So for every inch of rain, there is 0.6992 inches of runoff. Estimate the annual runoff for your rain if the rainfall is 54 inches. Well, if the rainfall is W, you would plug 54 in for W and get your answer. Mark this point on your graph and point E. How would we add this to our graph at this point?
Add an extra data thing and then make a new graph.
Add an extra data point. Okay, we can do that. Add an extra data point. So we would go, I don't remember which one I was just working on with you. We would add an extra data point. So we would put that, my computer's already saying no. So we would put 54 here and we would figure out what, oh, I've been making up that number, haven't I? 6.19 times 54 minus 9.78. And we would have to kind of reevaluate ourselves from there.
How is that possible?
How is what possible?
Like, how could it, like, so it's 27.6 and then 54 would be like a really big number.
Because I put the decimal place in the wrong spot.
Okay, I see.
Better?
Yeah.
It should be exactly right on the line, to be honest, because we're plugging it into the formula of the line. And so then you would have to edit your chart to include that point, although it looks like mine did that automatically. And it says to label them. I don't think it's going to let me label them. These were made to do in Excel. Range. Yeah, I don't think it's going to let you label. Mark your point. If the runoff was measured to be 11.5 inches, estimate the annual. Okay, so then we're gonna work backwards, aren't we? So we would have to go, if this is 11.5, this would be equal to 9.79. We're trying to find X. Plus 11.5, all divided by 0.619. And you could do the algebra yourself, but that also should end up right on the line. But that's a good estimate. Okay, so that would be part one. Part two is the same concept, and this is what you're gonna finish for homework and put in your portfolio, but now you have a BMX bike. So the weight is going to affect the jump height, so the weight is going to be X, and you are going to do the exact same thing you did before, but now you have a bike that you are dealing with. Do we have any questions?
So do we need to answer the questions according to the bike?
Yes, so tomorrow, this is it for today. So tomorrow, you are gonna do the BMX stuff. Enzo, no, we are gonna be doing part two tomorrow. This is class today. We are done with class today because it's only a 45-minute class and we are about done. Okay, so today you are done. Tomorrow, I did most of part two on accident. Good, you're ahead. So tomorrow you're gonna do part two. That'll be your submission. You are going to put it on your portfolio. Do we have any other questions before I undo all of this?
Wait, so we don't have to do anything today?
This was it for today, correct. Okay. You are done for today. Your attendance has already been taken as long as you are in this room.
And this is all recorded for Google Classroom, right?
Yes, and I will post this on Google Classroom for our assignments.
Cool. Do we have to change the grid lines?
You don't have to change the grid lines.
And then the numbers, are those supposed to appear on the graph or no?
You don't need those either. Those are just extra things.
Cat says hi.
Who says hi?
Cat.
Cat?
Cat.
He's been stroking his cat all of class.
Okay, congratulations. Okay, any other questions?